All right, so once we have it set to 0, we want to combine it so it's one fraction. So what would our common denominator be? X plus 3, x minus 2. Okay. So what is our first denominator missing? X minus 2. And then what is our second denominator missing? X plus 3. So we can rewrite this as 3 times the quantity x minus 2 minus 3 times the quantity x plus 3, all divided by that common denominator, x plus 3, x minus 2. That's going to be greater than 0. Okay, so distribute. So we have 3 times the quantity of x minus 2 gives us 3x minus 6. Negative 3 times the quantity x plus 3 gives us negative 3x minus 9. All over x plus 3 times x minus 2 is greater than 0. Combine like terms in our numerator. So 3x minus 3x, 0, cancel. And what's negative 6 minus 9? Negative 15 over x plus 3 times x minus 2 is greater than 0. Okay. So now we have one fraction. Helps if I actually close this. There. Okay, so looking at our numerator, do we have any variables? So are we going to have any x-intercepts? No. Okay, so we have no x-intercepts because there are no variables in the numerator. Okay. And then we want to look at our vertical asymptotes. Okay, so based off of our denominator, we have x plus 3 equals 0 and x minus 2 equals 0. So what are your vertical asymptotes? X equals negative 3 and x equals 2. And that's what's going to go on your number line. So negative 3, 2. Okay, so this is where you have options. You can either use your graphing calculator and graph the function and figure out where it's positive or negative, or you can use your test values. Okay, I showed you how to use the test values in the Edpuzzle video. So let's look at the graphing calculator. So, oops, maybe this will, hold on a second. All right, sorry. All right, so I'm going to plug in our y equals is going to be that fraction. So let's see here. We have negative 15 over the quantity of x plus 3 times x minus 2. Okay. If you have an older calculator and you're using your parentheses with your division, make sure you're using parentheses around that whole denominator. So you should have negative 15 divided by parenthesis, parenthesis x plus 3, close parenthesis, open x minus 2. And then we can look at our graph. Okay, so with that graph, we can kind of see where those asymptotes are and see what the function is doing. It starts off with being negative, and then as we move to the right, it falls up and becomes positive. And then on the far right, it's negative again, okay, because it's beneath the x-axis. So we need to look for our inequality, if it's greater than 0, are we looking for it to be positive or negative? Positive, which would be above or below the x-axis? Positive, above. Okay, so based off our number line. So to the left of -3, okay, which I wish I could write on this, would be over here. I don't know why I'm pointing at that. You can't see it. Let's see here. Okay, so the left of -3 would be where that little dot is at. Is that above or below the x-axis? Below. So that means this is negative. And then as we go to the right, okay, so between -3 and 2, the little dot is above or below the x-axis? Above, which means it's positive. And then little dot going to the right. So from 2 to infinity, is it above or below? Below, so that means it's negative. Okay, so we want to know where it's positive, and that would be this center section from -3 to 2. All right. The next thing we need to figure out is the parentheses and brackets. Okay, so since it's greater than, is that parenthesis or bracket? Parenthesis. So we don't need to worry at all about the domain. So our answer is just -3 to 2.